All right, today I'm going to talk about how to do a jigsaw classroom activity, which is absolutely one of my favorite things to do in a classroom for learning purposes. So first, a little bit about the background of a jigsaw. The idea of a jigsaw is that it incorporates individual understanding, group interactions, and teaching others all in one place, which is kind of neat. And so it helps students get their heads wrapped around something, but also forces them to communicate with other people and has them teach, which, as we know, is one of the highest levels of learning. It was developed officially in 1971 by Elliot Aronson at the University of Texas, Austin, and since then, it has actually been tested and used across numerous disciplines. It's one of the very few activities for learning that has, in fact, scholarly work behind it, which is one of the other reasons I like it. So, how does this activity work? Well, first of all, you choose an activity. You need something that can be broken down into about 5 or 6 pieces, each of which can be learned independently, usually with a little bit of guidance, so that you have to give them something to work with. Now, it can be done with pieces that are smaller. So I've done it with 4 pieces. I've done it as high as 8 pieces. It's just more complicated. Also, this kind of thing works well when you can have 5 or 6 pieces in groups of no more than 5 or 6. So typically, you're looking at activities that run between 20 and 30 students in a classroom. I've also done it with slightly less and slightly more, but that's really their sweet spot. The first thing you do is you create expert groups. So you make initial randomized groups. Each of their goal is to learn a piece. They become the expert on that piece. The next thing you do is you remix them. So you take the expert groups, you split them up, and you make new groups. Every new group should have somebody who's an expert on each piece of it. Then they come together and they share the information. So they teach each other. So now everybody has all of the pieces and everybody has learned a little something from another person. So that's the sort of basic overview of it. To get a little bit more into some of the ideas, some possible assignments you could do a jigsaw with. I do tables quite a lot. So there'll be large full page tables and it'll be something like the characteristics of 4 or 5 different groups and then the different types of characteristics. So I've done this with types of plants, I've done this with types of microbes, I've done this with many different things. And each expert group becomes an expert on one row or one section of the table. They know everything about that. When they get together, they all fill out the table as a group. You can also use simple problems. So if you give each group a slightly different simple problem, or sometimes 2, depending on what kind of thing it is, they have to work together to learn or solve or figure out the answer to it. Then when they remix, they could just share notes on the simple problems that they've worked on or work together on a larger problem that incorporates concepts from the smaller ones. So if you're doing something like math, you might give each group a actual piece of something that is needed to come together. In science, it's often that the problems are related to each other. And I'm sure you could do this in other fields, but that's not my field. You can do a concept review. So you provide the concepts to the students along with key things to define and learn. And this is a particularly good one for, did we do our reading or do we need to compensate for not having done our reading? So if you start off class with a concept review, each small expert group has to make sure they know the basic terms for something and then remix together and share that information, or better yet, remix together to now use those terms to solve whatever the bigger assignment you're working on for the day is, or at least share the stuff that you need to solve that assignment. And finally, another way I've used it in a really interesting context is in a case study. When I do case studies, I sometimes give each expert group a role in the case study where they have to learn a specific aspect of the problem or view it from a specific standpoint. And then when they remix, each group has another version of that role in them, and then they work together to solve the actual case study. So in microbiology, I have done this where I have a group that learns the microbiology of the microbe, a group that learns the epidemiology of it, a group that works on the pathology of it. And then when they come together, they have to talk about the idea of dealing with the next epidemic of that microbe. So it's worked out very well. So how do you make jigsaw groups? A little bit of the logistics so that people get the idea. You always begin by counting off to the number of topics or pieces. And I always say, give the students numbers. literally on cards so they can't forget. Because when you're kind of making vague groups, it doesn't matter if they come out exactly right. When you're making jigsaw groups, you have to get the right number of people in each group, or it's going to cause you chaos later. So do not assume that if you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, your students will remember. I hand out numbers, get them in their groups, and make sure the groups have the right number. I always check in with my expert groups before doing any form of remixing. I want to make sure that the student has the correct and complete information and that everybody knows that their goal is going to be to bring that information to another place. Then I remix to the smallest number expert group. So if your smallest expert group is 4 people, you count off 1 to 4 in each group. If it's 5, 1 to 5. If groups are bigger, they can buddy up. And so they could bring a friend to the next group if they need to. I would be careful not to let all of the friends go to one group, or when you remix, you end up with a very large group and a bunch of smaller ones. I'll show you this in a moment. And then finally, you check in with the remix groups and make sure they're doing the job they're supposed to do, that they're actually teaching each other, that they're participating, that somebody is not letting their information get ignored, or that they're just switching papers to copy. So to give you a really clear example of this, if I did this with chemical connections or chemical bonds, there are 4 major types of those that we've got. So I'm going to do this with a small class so you can see how it works, but it will make sense. So I have covalent, ionic, hydrogen, and van der Waals. If I have 18 students and I initially hand out numbers 1 through 4, I end up with 5 people in the covalent and the ionic groups, 4 people in the hydrogen and the van der Waals groups. The first thing they do is they have to learn about their bond. Usually I will give them information like, what is the strength of this bond? What is an example of this bond? What is important about this bond? That way they have the same type of information. I might even set this one up as a table, depending on how I'm doing it. Next, once they have that information, I give them new numbers. So I have taken away their original numbers. I say, forget your old numbers. Let's give you new numbers. For the groups of 5, I give out doubles. So the covalent group has 2 1s, 1, 1, 2, 3, 4. The ionic group has 2 3s. That way it splits them up. The other groups are just 4 and 4, so it's perfect. Once they remix, now group 1 has 5 people. 2 of them have covalent, but they also have ionic hydrogen van der Waals. Group 2 has 4, 1 with each connection. Group 3 is the one where 2 of them have ionic, and group 4 is absolutely perfectly remixed. One of the other sort of secrets to this is if you have a couple of students who are very poor at connecting and getting information or collecting it to somebody, you can make sure they're in the larger groups in all cases. So kind of guide them to the spot where they're in the bigger group and then make sure they're the one who shows up with a buddy into the other group. Because usually people do a good job, even not your best students do a good job of at least collecting the information and carrying it around, but you know you've got 1 or 2 that are trouble. This is one of the ways to deal with that. So some key tips to make your jigsaw work right. Everyone has to participate. This is not an optional, let somebody sort of sneak through activity. I am very clear with my students that the first group, everyone has to join up. Everybody has to have the info because they're going to bring it to the next group and they are not going to have somebody to help them. So everyone absolutely must participate. If they're not going to participate, I will at that point ask that they not be in class that day or that they leave and go do an alternate activity. You got to check that the information is correct. I very clearly check in with my expert groups before remixing because this is where you're going to catch the errors, the misconceptions, the things that they're going to mess up. This is also where you get them interested in something so you can tell them the neat story about whatever it is, and it's only a small group. Then they tell the story the next time around. So checking in with your expert groups and making sure they're also very confident before you remix is important. Make sure everyone has very clear instructions. So each group needs to know what their goal is. The expert group needs to know what their goal is to fill out a table, to solve a problem, to define these terms. After remixing, you also need to be very clear what the goal is. Sometimes the goal is teach each other the information so that everybody has a filled out table. But sometimes the goal is share your ideas to solve this bigger problem. And don't let them get too caught up in giving each other information when there's a bigger problem to solve. So clear instructions is important. And then finally, one of the things that makes this work is that they do teach each other and they're not just copying. So students are very much known, especially with tables, to just swap a thing and then write it down without looking that carefully at it. So I monitor my groups and I say, the idea here is that you tell each other the information. I don't want to see you just swapping papers. I want to see you talking. I want to see you communicating. If they're not doing that, I stop them and make them switch. So monitoring the process no matter what is actually pretty important. You as an instructor are very active during a jigsaw. You're just not doing as much direct instruction while it's all happening. Finally, I've got some alternate ways to share information or the way you might do something. Sometimes, even after doing a combined version of a jigsaw where they like talk to each other and they mix and remix, I will still collect the information in some way. We'll have people come together and put it up on the front of the board so that it's all written down or in some kind of shared digital document, and groups add their items to the whole. Sometimes I do this as a regular and don't do a full remix depending on where I'm at, or we do it to make sure that if I don't have enough time for a full remix, everybody still has the information. Another thing I do, which isn't a proper jigsaw, is a random remix. So after the initial groups become experts, I let them be a little less structured and say, hey, fill out the rest of your table. And a lot of times what you have is students pair up, they share their information, then they split and go find another pair and share their information. And that can be good in a class that, first of all, can be trusted to get the work done, or in something that you're either going to collect or they're definitely going to use. You sometimes have to prod them to move a little bit more because students don't love getting up out of their seats and going somewhere. So you got to pick and choose when this one is going to work. And then finally, something that's a little different from the other things we do is a process discussion. And so this is where I tell my groups that even though you've become an expert in something, the content is less important than the process we used to get there. So I have a jigsaw activity in microbiology where the students are identifying drugs to use for different microbes. And at the end of the day, they don't need to know every drug they chose for every different microbe in the table, but they do need to know how